My name is Robert Finlayson. I'm a Senior Product Manager at KPMG Australia. We utilise Azure Cosmos DB NoSQL database to store our conversational histories for KimChat. For the implementation of our retrieval augmented generation model within KimChat, we leverage Azure Cosmos DB for MongoDB vCore for storing our document embeddings. The utilisation of both Azure Cosmos DB ensures that our architecture supports our highly efficient data storage and AI retrieval processes. For us, it's the new HNSW vector index. It's a graph-based data structure, and it's dramatically improved our search results and the performance across our document data set.
Hey everybody, welcome back to the Azure Cosmos DB Global User Group. It is the April 2024 edition, and my name is Jake Wood. I'm your host. I'm a Senior Program Manager for the Azure Cosmos DB team. And so what do? We get together pretty much every month. Yeah, we get together every month, and what do? We talk about Azure Cosmos DB. What kind of conversations do we have? Well, every month we try to make an opportunity to grow together with sessions featuring members of our amazing community, along with some Microsoft experts. And this month we've got a great one. If you want to know about retrieval augmented generation, you want to know about Semantic Kernel, you want to know about Azure Cosmos DB for MongoDB utilizing our vCore based offering. I've got so much to have shared with you today. I've got some really great guests, people that you're going to enjoy hearing from. We've got Kailan Modi. He is from Microsoft. We've got John Aziz. He is from GemMinds. They're going to share their expertise, provide some information about these retrieval augmented generation. We're going to talk about AI in general. It's going to be a great session. And to have a great session with our guests, we need to do some things. We need to get some housekeeping out of the way. And the person that always helps me with our housekeeping is Askia from the Reactor team. How you doing? It's good to see you.
Yeah, good, Jay. How are you doing?
You know, it's sunny out here in New York City. It is getting warmer, and I'm loving it. I'm up to just hoodie weather, and yeah. I'm loving it.
Yeah, same here. We've got some sunny days in Seattle, Redmond, so things are good. But as you mentioned, before we get into today's session, we do have a little bit of housekeeping to attend to, which is basically our code of conduct. So we're going to ask, it's pretty straightforward, but we ask that you provide a respectful environment for our presenters and our guests. We encourage engagement in the chat, but we want you to be professional. Please remain on topic and be mindful of your commentary. We're going to share useful links throughout the chat. And one thing to keep in mind, this session is going to be recorded and will be available for on-demand viewing on the Microsoft Reactor YouTube channel pretty much within 24 to 48 hours. Today's session will run approximately 1 hour, and there will be time for questions throughout. So with that said, that brings us to today's session. I will hand it back to Jay and let that get started.
I will see you at the end of the show. Thank you so much. Always appreciate your time. Now we are off to our guests being welcomed here. The first person I'm going to bring in is Kailan. Hey, Kailan, how are you today?
Hey, Jay, how's it going?
It's going great. I'm always happy to hear from you. Kailan and I work on the same team. We do so much in the Cosmos DB organization to help share, spread, get you to want to utilize these products. So he's going to have a lot of great information for you. And then we also have John Aziz. John is from GemMinds. You are a Microsoft MVP, and you are one of the reasons why we are doing this session in general. So welcome.
Thank you, Jay. Hey, everyone. Thanks for having me.
Absolutely. Hey, everybody, we're going to give you a big wave. If you're watching right now, tell us where you're watching from. Put it in the chat. I'm in Brooklyn, New York. Keelan, where are you?
I'm in Redmond, Seattle.
With HQ, the mothership. And John, where are you located?
I am based of Egypt, Africa.
Wonderful. Thank you very much. So, one of the things I always like to do, we're going to talk about today's subject. We're going to get deep into this, and I know you both have some really awesome information to share with us. And I think you've got a demo too. So I'm really happy to watch all this. John, I've seen your blog post. I've seen some other stuff around all this, and I'm just really excited to see it. But here's the thing that I really like to do is I like to give our guests an opportunity just to give a little introduction to themselves, how they got here, and what they're currently working on. And so, John, I'm going to give you that opportunity first. So, John, when I ask how'd you get here, I mean literally, like, how'd your career bring you to this point where you're here on this show today?
I'm passionate about AI like everyone around the world right now, and I have been passionate about it for the past few years. And I guess this led to me becoming an MVP in AI, and then, of course, sharing the knowledge and learning about cool stuff that Microsoft brings and all of the other technologies that are around that you get to try and test and really experience the new stuff that is out there.
Great. Thank you so much, John. And Keelan, I know you well, but I think our audience may not. So why don't you tell us a little bit about how you got here too?
Yeah, that's a funny, it's a fun story, to be honest. I went to Georgia Tech, did my CS over there. And during the wave of AI, I think a few months before, I was just too interested in AI and I'm working on a bunch of my own samples. And when I got to join Azure Cosmos DB and I got to know that Azure Cosmos DB is the database behind ChatGPT, I was like, you know what? I got to get into this. I got to get to work more on these samples. And that's why I'm so excited for this session, because it's John and I, we're both passionate about Gen AI and like RAG type applications. We're going to have a perfect session today. And I feel like it's going to be really good for our audience to learn more about how these things work behind the scenes and how you can get started with a step-by-step demo.
Fantastic. So before we jump into it, I'm going to give you the floor. I'm going to let you run all over it and show everybody all the cool stuff. But before we get into it, I want to remind everybody that if you have questions, comments, anything, go ahead, put them in the comments section in the chat. Remember, please follow our code of conduct, be cool to one another, be professional, but also be welcome to ask questions and comment to each other and give each other assistance. This is a session for you, our viewers, our community. And that's one of the reasons why we have John here. John's a member of our community, and he went out of his way to go ahead and build something to share with you. And so that's what he's going to be doing today. We're going to be talking about retrieval augmented generation. We're going to be talking about Semantic Kernel and Cosmos DB for MongoDB using the vCore offerings. So with all that being said, John, I'm going to pull up your deck, and I am going to give you to the floor. So everybody, leave your questions. I will be in the chat room. I'll be paying attention. I will be happy to relay them. But for now, Keelan, John, please.
Thanks, Jay. I think we're going to get started. So our session is going to be about RAG using Semantic Kernel and Azure OpenAI, and we're going to use the vCore-based Azure Cosmos DB for MongoDB vCore. Today, I'm here, as Jay mentioned, I'm joined here by John Aziz, and I'm Akhil Modi. I'm a product manager on the Azure Cosmos DB team. John, do you want to say a few words before we get started?
I guess we said enough at the beginning, but I'm really, really passionate about about what we do and what we are doing today, and that's why we are doing it. So if you're interested, make sure to join us and tag along, and do try to do it practically with us today.
Yes, feel free to put your questions in the chat, and also we're going to have a link to connect to the GitHub code space. So if you want to go ahead and work along with us, feel free to do it and leave the questions in the chat. We'll try to answer them as we go along, and also we'll have a dedicated Q&A session at the end. So the agenda for this, we're going to have a prepare section. We're going to show you what you need to get started with this with the application. We're going to go over a few concepts. We're also going to go over like some of the Azure Microsoft technologies that we'll be using for this. We're going to show you the demo. And finally, we're going to have the summary and the Q&A. So let's get started. Let's do this, John.
Yeah, sure. So because this demo includes creating lots of resources and this might take some time. So we have a smart way of doing it. And all you need to follow along with us is an Azure subscription and Azure OpenAI access and a GitHub account. That's it. That's all you need to do. And if you are a student, you are eligible for the Azure for Students offering. So you can do that too. So the first step is that we want you to open this URL, which says aka.ms/rag-sk. And this is the GitHub repo that has the code that we will be walking through today. So click on this URL, and then it's going to take you to the repo. And then click on code, choose code spaces, and click on the plus sign to create a new code space. And what this is going to do is that it is going to install lots of stuff for you. You don't have to install it yourself. It's going to be installing the libraries, the code is going to work right away, and you won't have to worry about if you have a library installed or not and all of that. Then the second thing that we will use to help us is AZD. Have you ever heard about AZD, Kailan?
No, what is it? Do you mind giving a brief intro?
Yes, so AZD is a cool tool that creates all of the resources and deploys all of your code to Microsoft Azure. So you have your app code, and you have some infrastructure as a code or some bicep files that has the resources that you need. And then you type one command like we will see, which is AZD up. And this is going to do all of the magic. So it's going to take your app from here to Microsoft Azure. And all
Wait, so you're saying
is
with one code, with one line, users or viewers are going to be able to deploy this application with Azure AZD up?
Yeah, and it's an AZD template, by the way. So it's available in the AZD template gallery. You can go ahead and check it out. And like you see, we only need to log in and do AZD up. And it's going to create the Cosmos DB vCore and everything, and also deploy the code. So let's go ahead and do that. So
before we go, viewers, I feel like it's easy, I think it's pretty easy to get started with this. So I really recommend going into AZD, logging into your Azure account, and then just doing AZD up, and like follow along.
Yeah, you can. So this is the code spaces. After it loads, this is what you will see. All you need to do is to make this a little bit bigger, and then try to type AZD auth login to log into your account. And then it's going to ask you to sign in. I am signing in the background right now. And after I do sign in, it's going to know my my subscription and everything related to authenticating me. And as you can see, it's retrieving the subscriptions right now. And then I can do AZD up, and it's going to ask me for a name for the environment. So let's name it Reactor Demo. And then it's going to ask me, where do you want to deploy these resources? Let's see. Oh, the subscription first, of course. And then where do you want to deploy it? For example, I might choose East-US, and it works. That's it. So now it's packaging, provisioning, deploying, everything is working in the background. We get to continue with our session.
Cool. Do you want to talk about the architecture of how the thing works in the behind the scenes?
Yeah, sure. So this is all of the resources that will get created, and it's gonna create an Azure Cosmos DB for MongoDB vCore for us, and it's gonna create an Azure OpenAI resource, a key vault, an app service, and an app service plan. And this is like the full website with everything. And we just sit and relax, and it's doing stuff for us. So right now, we are going to demo the final website for people to learn more about it and see what is it, what are we doing.
All right, let's take a look at the website.
Yeah, let me pull it up. That's it. So this is the website. You can ask it about movies, and it's gonna recommend or tell you movies related to what you are asking it about, or try to recommend similar movies, or even tell you more about your favorite movie.
Interesting. Let's see if it works. I'm a big fan of like crime dynasty movies, like the mafia movies.
Okay.
So let's ask it a question regarding that. Let's see how it goes.
Okay. Let me try to say, do you know any crime dynasty movies? Yeah, it
Oh,
knows.
that's the
The
classic.
Godfather. It is. And I guess we can ask it, what is The Godfather about? Like if it does know more about it or it doesn't. So it's gonna say, yeah.
Okay.
Yeah.
Can you ask it a question to like recommend movies based on like description or based on something that you prefer?
Yeah, sure, you can. And we can like make it recommend movies related to a movie that we have just explored. Like for example, I can ask it, do you know or recommend movies similar to The Godfather? And guys, do make sure to drop your movies in the chat and let us know what you want to ask it. And we will surely try to do it live. So it's struggling a bit, but it got it.
Okay, I see Godfather, Goodfellas, Scarface, Departed, Casino, and Once Upon a Time in America. That's nice. I think it gave us like good recommendation based on similar to Godfather. What else can we do with this application, John?
I guess you can ask it like about movies, but it's limited to the database that it has. So it will only know the movies that we have in our database. So
Okay.
maybe let's try to ask it, what do you know about the Goodfellas? Maybe this movie is in our database, or maybe not. Let's see. Oh, it is, I guess.
Okay.
So it does know about it, but let's try like a random movie like Titanic, for example. What, I don't think that this is in the movies. So what do you know about Titanic? Okay, so it does say that I don't know anything about the Titanic movie. How about we try to make it do something else other than recommending movies? Like, can you give me something, Kela? I don't know.
Let's see. Let's ask the chat if they want to do something with the application. We can do. I know it's pretty good that we doesn't have. I think someone like brought the question up. Does it do TV shows like Space 1999? Do we
I
have
don't
like
think
TV show
so.
data in it? No, right?
No, but like let's try to see.
Okay.
Do you know what is the name of the TV show?
Space 1999.
Space
1999. Yeah,
1999.
191999. Yeah.
Oh, 191999. Okay.
Yeah. Let's see if it works.
It doesn't know, so it does not know. So as you can see, we have a grounding, and it's like responding to the things that it only knows. And like what I was trying to make you say, or to explore with you, is whether it is able to do other stuff like large language models are able to do everything, basically. So do you know good hiking places? Yes, good hiking wrong. Okay, so it can. So it's only going to respond to movies, and it will respond to the movies that it knows. And that's
Okay, that's
really
a good thing. When we go into our code, we should like see what you did to make sure that it only gives us the answers from the database and not like random stuff from the internet. I think we'll take a look at this at the code. I think someone had a question. Does it hold the context from the previous chat messages? And I know we have an optional session like talking about like chat history with Semantic Kernel. I guess we should like demo that as well at the end of this presentation. So let's go on to the concepts that we will need to get started with this.
Yeah, and like someone asked, yes, we will try to demo the chat history at the end. And yeah, so the introduction, the concepts that we have, and this is the whole flow that is happening in the background right now. It may be a little too much, but this is exactly what is happening, and you can't see anything. So it all starts with your data. We have some data, which is the movies data set that we are going to talk about later. And this data is chunked and fed into an embedding model to generate some embeddings. We are going to get to that later too. These embeddings need a place to be stored in. So which place are we going to store it in? Kelan, I guess. We're going to store it in Azure Cosmos DB. And can you tell us more about Azure Cosmos DB?
That's the product I work on. Yeah, I would love to talk about Azure Cosmos DB for MongoDB vCore. So one thing I think someone mentioned in the chat that is it going to cost me more than $100? I said, I have a good news for you. Azure Cosmos DB for MongoDB vCore there is a free tier. So if you sign up for it, it's not going to ask you, it's not going to charge you anything. And also you can like sign up for the Azure OpenAI subscription with your student email or any other email. I feel like they also have like a free tier, like a standard subscription that you can go to. So I feel like it's not going to be more than $100. But yeah, going back to the Azure Cosmos DB for MongoDB vCore, it's a integrated vector database with built-in vector search. It also has vector indexes right in the database. So you don't have to keep moving your data around in order to do these operations. So it's all in one database so that everything is under one roof, and it has integrations with other Azure services. So again, it's pretty good.
Yes, and that's why we are using it. So we are storing the embeddings there, and we are storing the data inside Azure Cosmos DB for MongoDB vCore. So everything is in one place. And then when someone asks a question, like for example, the one that we asked, the Godfather question or any other question about a movie, we convert it into embeddings using the same embeddings model. And then we compare between the embeddings that we have in the database and the embeddings that got generated from the user prompt. And then if they are similar to each other, we feed to the large language model and we try to make it generate a response that is human-like. So it's not talking like from the data, we are going to see the data itself, like how does it look like? It does not look very good. And it's not like a conversational data. So the large language model is making it like a conversation or a chat. And what we have with this flow is that we have grounding from the search, because now it's only responding from our data. It's not responding from anywhere. And we can support having the the data like from our own data set, not like from any other data or publicly available data. And then the response is returned to the user. And this is like a recap for everything. So RAG is intelligently retrieving a subset of data from data store to provide a specific contextual knowledge. Who is going to do that? The large language model. And it's going to support it to answer the user prompt. But I guess people might ask this question. And I guess you do ask it to yourself, Kellen, right? Or
yeah, why do we need RAG? Why RAG, basically?
I guess, yeah. So, and this is a really good one because as you saw, it's providing grounding and context to the large language model. So we're not letting it loose. So it can't say anything. It can't like respond to hiking recommendation questions or respond to anything that it can do. And it can do a lot, by the way. But like we are grounding it and giving it context to respond based on. And that makes it easier for us to work with it and makes it more beneficial for our use case. Also, we are overcoming a very big problem, which is the outdated training data limitation. So all of these models get trained to a specific period of time, and then they are released to people to use it. So when you ask it about something that happened really recently, it does not know. and it might give you wrong responses. And now we are giving it our data, so we are basically giving it whatever we want, so we can overcome that and make it know the recent updates in any domain that we want to make it know about. And also, it's
Do you want to explain RAG like in one sentence for our audience who are new to this like terminology?
So RAG is, we are getting some data from our database and then making a large language model give us an answer to a question based on this data. So that's RAG. We are grounding it to respond from what we have in the database. And also this.
Let's take a look at the data and what data we're using for this RAG application.
Yeah, sure. So we are using the IMDb movies dataset, as you may have noticed, and it's like a JSON document data. This is how it looks like. It's like the Godfather, the aging patriarch, and that's why we need the large language model to parse this and try to make it like human-like conversation.
So how is it able to convert the question into, how is it able to understand the question and like get the answer from the database?
So it's using the embeddings, and it has like the embeddings comparison. So these are what you see on the screen right now. These numbers are embeddings, and it's generated from the text. So it takes the words word by word or letter by letter, and it tries to generate numbers from, and these numbers are the embeddings. And then we use like Azure Cosmos DB or the vector database that we have to make what? To compare between the embeddings and store them. So we have our data, which is already stored, and someone is asking a question. We use the embedding model to convert both to vectors and then store it and search over it in the vector database and retrieve or return the top 5 similar vectors from it. And because this data, that's how it looks like. It's not very friendly, I guess, or human friendly. So we need the large model to make it what? To generate text and to make it like reason about what it is doing and how it does it. And that's it.
Oh, nice. Okay, now let's take a look at the Microsoft technologies that we need for this, and then we can get into the code.
Of course. So we have Azure OpenAI, of course, because we need something to be our large language model, which is the chat deployment. And you can say hi, and it says hi. You can have a conversation with. And then the embedding deployment, and this is converts text to embeddings and vice versa. So this is the one that is generating the embeddings, and then it is generating the text from the embeddings. Or if you needed to do that, it will. Okay, so if you want to know more about it, you can go to this URL. But for now, we're going to talk about the Azure Cosmos DB for MongoDB vCore with Kellan, I guess, can shed the light on.
Yeah, I can talk about this. Yeah. So with Azure Cosmos DB for MongoDB vCore, we have like built-in vector search. So when we do like a vector search based on the query data, on the query that the user prompts into our chatbot, it returns like top 5. It goes into the database and looks at the similarity score with the data that we have in our database. And then based on how many recommendations you need, it returns the top 5 or top n similar products. For example, if I ask it a question to like recommend me bikes that are good for like Seattle weather, then it's going to go into the database, look at all the description, and then recommend me products based on the similarity score. It is able to do this because we have built-in vector indexing. It's either IVF or HNSW. So think about indexing as the same thing that we have it in our book. When you read a book, we have like an index page in the beginning where it tells you what page or what chapter is on. So similarly, our vector indexing knows where to look for data. So it basically goes there, retrieves the data, and sends it back to our application. So this way, you're not spending too much money by looking in everywhere in your database, because that could get like really expensive. And that's a pretty good thing about like Azure Cosmos DB for MongoDB vCore, you're able to get built-in vector search, built-in vector indexing right in the database. So you don't need like a third-party services for that.
Yeah, and I guess this makes it really simpler for us, or simple for us to manage, because like we don't have to care about all of the resources or lots of resources on Azure or on our cloud. We only have to care about the Azure OpenAI and Azure Cosmos DB for vCore. Someone asked a question that says the top 5 similar vectors. Well, that's for later. When we discover the notebook, you are going to get to know what are we doing exactly. So the last thing that we are using to build or to combine all of this together is the semantic kernel. And the semantic kernel is what is providing all of the code that we are going to demo today. So all we needed to build this from scratch is the technologies that we discussed. But now we need some code because these resources are created. Yeah. And they are linked together, but now they are doing nothing. So how can we make them do the RAG and do the vector search and all of that? We are using the semantic kernel because it's a user-friendly platform or coding orchestration tool that we can get started with easily, and you will see how easy it is to get started with it. And it is giving us from it a way to create the database, to create the index, to create memory and history, and to do stuff with OpenAI and embeddings and all of that. So the semantic kernel will be the base for all of the code that is making this work. And we're going to check it more in the demo. But before we do that, Kellen, can you tell me how to create the Azure Cosmos DB for MongoDB vCore?
Yeah, so there's a very simple link. If you want to type it in the browser, let's do aka.ms/try vCore, and it's going to take you to this page where it's going to give you the step-by-step guide of how you can create Azure Cosmos DB for MongoDB vCore cluster. For the sake of this, let's click on sign into portal, and I'll walk you through the steps. So once you sign into the portal, you want to go ahead and create a resource, or you can click on Azure Cosmos DB. If you have it right, you have it right there. You're going to click on create. And you're going to enter your subscription and resource group. And then we're going to give our cluster a name. And then we're going to check the free tier option. So with this, you won't be charged anything. It's going to be completely free. And you're going to have 32 gigs of storage with your free tier. And then you're going to click on select location dropdown and click on the location that you want. And then you can select MongoDB version 5.0, 6.0, and we're going to soon have 7.0 in MongoDB. Yeah. Now let's click on admin username and give it a password. And let's go to networking tab. Right now, either you can have like private access to your MongoDB cluster, or you can give like a public access. So let's do a public access for now, and only enable it to your current IP address. Click on add current IP and click on review and create. So that's all the steps you need to create a MongoDB cluster. For the sake of the presentation, I know, John, you've already created one.
Yeah, I did.
Maybe we can go on to the next step. And also answer the question that we had in the chat. With MongoDB vCore, Azure Cosmos DB for MongoDB vCore, you can store your embeddings right in the database. So you don't need to store them separately. And I think John has a demo of how you can create those embeddings and how you can store it in the cluster. So we'll talk about it in the later section. And also, we do have a VS Code extension for Azure Cosmos DB for MongoDB vCore. It's called Azure Databases. So you can find it in VS Code extension tab and go ahead and enable it. So that also gives you the experience to get started right there.
Yeah, and now I guess we can demo the creation of OpenAI resource for those of you who have never created an Azure OpenAI resource on Microsoft Azure. So all you need to do is to search for OpenAI and then click on create. And it's a similar resource. So all we need is a resource group, for example, like a cool RG, and then the region is anywhere you want. And then the name might be my OpenAI reactor live demo. Anything will work. And then there is only one pricing tier. There is the networking, of course, just like Kellan showed you. You can allow all the networks or select networks like a VNet, or even disable it and make it not available for any network. And then you can add more some tags to it, and then that's it. You have it. And now is the time for our second demo.
Guys, let's take a look at how everything works behind the scenes. Let's take a look at the code.
Sure. So this is, again, the code spaces. And by the way, it's still working in the background, but I'm just going to minimize it for us to focus on the code that we have for today. So the first step for working inside the Jupyter notebook is that you select the kernel. I have configured this with Python 3.12. So please make sure to choose that. And then you can install this, but if you open it in code spaces, you don't have to install the semantic kernel again. Then the second step is to create a .env file like the one you see here. And this .env file will have the deployment name, the Cosmos DB connection string, the database name, the container name, and this will be used in the code. So these two variables are not created yet. We will create them live while we are working right now. So all you need to get from Azure is a chat deployment name, embedding deployment name, and then OpenAI deployment name, and the endpoint, and API key, and the connection string for Cosmos DB. That's it. Then let's load this, and yeah, let's talk a bit. But before we talk, if you have a question, make sure to drop it in the chat. And yeah, so some of the things that we are going to get to today are handled by the semantic kernel. So it is creating the index, the container, or the collection for the data, the database. So it's doing a lot in the background. And all we need to do is just to import the code and give it the names, and it's going to work. And in this guide today, we are using the text embedding EDA 002. And this embedding model, or any embedding model, will have a links for the embeddings that it will generate. And we need to store this links to create the embedding index, or the vector index, with the same vector dimensions that we have. And then this is the name for the index and the type of similarity. There are 3 different types available in Azure Cosmos DB, like the cosine, the L2, or IB, and you can read more about it here. And the number of lists is a parameter specific to the IVF index, or the inverted file index. And this specifies how many clusters it will create to group the vector data that we have.
Mm-hmm.
And then this is a helper function. This is a simple helper function to help us check if the data is there. If it's not, add it to Cosmos DB. And all it does is that it checks if the data is already inside Cosmos DB. If not, it will try to save the data and generate the embeddings on the fly. So the data that we have is the data that I showed you, which is this one. It does not have embeddings in it. And what we're doing is that we are sending this content and generating the embeddings based on it. So let's run this code. And now we need to initialize the semantic kernel. And in order for us to do that, all we need to do is that we import it and we create a variable from it. And then, of course, we will be working with Azure OpenAI, the text embedding, the chat completion. So we need that too. And we also, after we import it, we will register the service. The semantic kernel, to add a new service to it, like the Azure chat completion one, all it needs is the deployment name, the endpoint, and the API key. Like anything in the world, like what is the name of the service? How can I access it? What is the key that opens it? And then a service ID is like a unique name that you get to type. This can be anything to identify different services that you add to the semantic kernel.
John, I have a question. Where can the viewers find the deployment name, the endpoint, and the API key?
You can find it in your Azure portal. So if we go back to Azure and we go back to resource groups and we get to this one, and then we open Azure OpenAI, this one, there is a tab called keys and endpoints. When you click on it, you get the key, you get the endpoint, and this is the name of the resource. For the other ones, you will need to open the Azure OpenAI Studio, and you will find them in front of you when you open it, inside the deployment.
And all they have to do is like copy it and put it in the env file, and it should like run the application. Oh, that's awesome.
That's it. So now we add the second one. Did you add this one? Okay, I guess I ran it twice. So this is the chat completion one, like I said. And then this is the embeddings one. So now the kernel can do two things. It can do chat and do embeddings. So the next step would be to create our database. And while creating the database, it creates the collection and it also creates the index, all in one. This cool function that's called Azure Cosmos DB memory store. And when we run it, collection name, did I run the code that gets the collection name up there? I guess I did not. This is the collection name here. Here is it. Let me run it again.
And to answer the question that we have in the chat, yes, you are able to specify different embedding models. For the demo, we are using the text ADA002, but you can use any embedding model, even from Hugging Face or Azure OpenAI, and a bunch of other things that we support with Azure Cosmos DB for MongoDB vCore.
Yeah, I don't know why, but it reset my notebook halfway in. I don't know why did this happen, but that's cool. So it says text embedding what's happening? Did I run the, okay, I run the embedding one. This is the one that creates this one. Okay, I don't know why it's resetting my notebook halfway. Okay, so now we created the Cosmos DB for MongoDB vCore, and we added to the semantic kernel instance that we created. So make sure to differentiate between two things. There is something called the store. This is the database itself. And there is another thing called memory. And this memory is the semantic kernel memory. And it combines between your memory store that has your data and the embeddings generator. And this generator is what you use to generate the embeddings and store it in the memory store. And the memory, the semantic text memory, is what is able to do that, to link between both. Now we need to add our data set. And the data set name is cleaned. Let me check the name. Cleaned top movies chunked. So this is the JSON file name. And then I run it. Oh, I added JSON twice. So let's run it again. And it's gonna say skipping item already exists, because I did this in the background. and it's going to skip all of the 300 movies that we have. We have almost 400 movies in our data set, and that's a lot of movies. And they are top movies, by the way. So you can try to see if your favorite movie is in the data set or not. Just send us in the chat what movies do you want us to ask it about. And right now, after we do this step, it's finished now. We are going to try to test the vector search. So I guess we can ask it about The Godfather again, or anything that you can suggest, Kellan, other than it, because I don't have anything in my mind right now.
Let's just do like Godfather. Let's just do what. Let's do the same question to see if how it works.
Okay. This is, by the way, this is the vector one, not the one that we used in the web live demo. So now in order to do the vector search, it's really easy. You just tell it your collection name and you give it the question. That's it, to a function called search. And then let's see the first result returned from it. Wow, it says that the similarity is 78%. That's very high. It says the Godfather is the aging patriarch. Yeah, I guess that's
I have a question.
same.
What is the embedding based out of? Is it defined on the content field, or is it defined on all three of the fields that we have in our data set?
So it's defined on the content, and that's why I chunked the title of the movie with the content or the description of it, so that the large language model know the description and the name of the movie, not just the description of it. Okay, someone said 2001 Space Odyssey. We are going to try this with the RAG. And yeah, now let's see the RAG. So this RAG example, and what we do here is that we are telling it a prompt. And this prompt is what is controlling everything. This is really important. This is the most important step. So we're telling it, you are a chatbot that can have a conversation about any topic related to the provided context. Give explicit answers from the provided context, or say, I don't know, if it doesn't have an answer. And this is your provided context, and this is what the user said, and this is what you will say. So that's how you instruct the LLM or the large language model to do something. And
so the provided context is the database, right, that we are connecting to, and the user query term is the question that they ask to the chatbot, right?
Yeah, but this is not like the entire database. It's only one record from it. Okay. So let's see how we do this, how we do the one record thingy. But before we do that, in order to use Azure OpenAI, we will need to specify some execution settings, like what is the maximum number of tokens that we wanted to use for each request, what is the temperature, and what is the top probability percentage that we would like to use. And this is how you make it do stuff in a specific way that you get to control. And the temperature here specifies whether it will be creative or not, or will it be strict in responding to the questions? Will it be try to follow the rules that you put to the letter, or will it deviate from it and try to be generative, I guess, and try to create more stuff and fictional responses? And this also decreases the probability that it is generating like random stuff. And then let's run it. And then we need a prompt template config. So we have the execution settings. Now, what is the template for the prompt that the user will ask? Okay, so what is the template for the config that the user will ask? So this is how the user asks a question. We have a template here. This is the prompt, and we have like a name. This is a random name for it. And this is the template format. This is the semantic kernel template format. And this prompt is the prompt that we defined earlier. And then we define the inputs. What does it need? So it needs these two things that are inside the curly brackets. It needs a DB record and the query term. This is the query term, this is the DB record. They are input variables to our Brombit template config. And then we pass along the execution settings that we talked about. And just like that, we can like add a function, give it a cool name and a cool plugin name, and then give it the template config that we just talked about. So let me run these cells so it does not complain that, oh, it does not know. I did not run something like usual, live demos. So right now, I'm just running stuff because I was talking but not running. And then we add the function to the kernel. And right away, we try to invoke it with a question. But this is taking the query term. What is this query term? And the DB record. So the query is the question that the user inputted, that we inputted here, which is what is the Godfather? What do you know about the Godfather? And then this one, the DB record one, is like the first result that the database returned. So let's see it. So we are only giving responses based on the most relevant record, not the top 5 records like someone asked. Someone is asking, oh, we have a lot of cool movies in the chat. We're going to try them when we get to the demo. So finally, yes, it works. And it's doing the RAG that we have. So let's test it and do what you asked, like the movies that you sent in the chat. And can you help me, Kellan, and like tell me the names of the movies? I'm just gonna.
The 2001 Space Odyssey. That's the movie that was recommended in the chat.
Okay, so before we do that, what are we doing here, guys? This is a simple function. It's just taking an input, and then we are doing search over our database. This is all of what we did, but in like a few lines. And then we are trying to do the RAG here with our returned database record and the question. And then we are displaying the response. We are just printing it. So let me run it. And let's see. Someone said the message. Oh, let me try. Let's say hey first. So hey. Hello, how can I assist you today? It's working. It's a cool thing that it works. Then we can ask it, what do you know about the movie, The Message? It doesn't know about the movie called The Message. And let's see, does it know about 2001 Space Odyssey?
Is it because we don't have it in the data set?
Yes, because we don't have it in the data set. About the movie Space Odyssey? Is it like that? Or am I typing it wrong? No, yeah, I did.
SSEY, yeah.
Okay.
And guys, I'm going to also stop in. It's 2001 Space Odyssey. As one of the sci-fi nerds, I'm putting it in.
Oh, so we need to make it like 2001, but I don't think that about the movie. I don't think we have movies that has numbers in their name.
So yeah, it's 2001 : A Space Odyssey. So
it's okay. It doesn't matter if we mess up. Even if we do typos in the name, like if I say, "What do you know?" It's gonna try to guess. So what do you know about the Matrix, for example? But like maybe I do it Matrix with EX, maybe. So it does know it. Can you see? So it's typo.
Okay, so only we're not able to recommend is because we don't have any data set. We need to add more data. So let's take a look at adding like chat history. I know we had a question about adding chat history. Let's take a look at that, and also let's take a look at how we can add our data to our data set and how to create like embeddings.
Yeah, it says goodbye, take care. That's really that's really
He's a good agent. He's a good agent. He's not gonna take over the world.
Yeah, so yeah, by the way, let's see how can we add the data from our app service. There is another way you can add the data. So all you need, this is the created resources by AZD. You are going to open the website and you will SSH inside the website machine. And why are we doing it from the website machine? So we don't have to include our IP address into Azure Cosmos DB. So this is the securest way of doing it, because we don't have access to the Azure Cosmos DB, but we only have access to the website, which has access to the database. So we can do it from the website like a tunnel connection to the database. And yeah, it's a simple script that I created. You just need to type Python and then scripts add data, and then give it a file, a JSON file with your movies. The only trick is that it needs to have a specific columns like ID and title and content. If you don't have that, I have like a how-to guide in the main README that will help you overcome this problem. So now we say .forward/data, and then we say cleaned, that's chunked. I guess it's top movies chunked, or cleaned chunked top movies. I can't remember. Let me check it. Cleaned top movies chunked. So cleaned top movies chunked to JSON, and it's going to take some time because it's trying to connect to the database, trying to open the file and doing lots of stuff. But now it's going to say generating, because this is the new database. This is the new website that does not have the data. And it's generating the embeddings and saving it to the database on the fly. We're going to cancel this because I don't want to consume my...
I think this answers the question that we have in the chat. Like, what are the benefits of using this using MongoDB for Azure Cosmos DB for MongoDB vCore? Is because like we are able to store your embeddings. You're able to like generate embeddings for your data and store it right in the database.
Yeah.
So again, you don't need like two different services to store your embeddings as well as like data. With MongoDB, Azure Cosmos DB for MongoDB vCore, you can store your operational/transactional data and vector data right there. So it's better. Like everything is under one umbrella.
Yeah, it is. And now is the last part of the session. Great. The last part is adding the chat history. This is a 5-minute thingy. So so sorry for delaying you a little bit, but let's get to it and see how can we do it, Kellan. So the first step is that you need to search for the Semantic Kernel GitHub repo. And when you open it, it is gonna show you the main GitHub repo. They just, I'm not sure, did they? No, they didn't. That's good. So this is the GitHub repo where all the magic is happening. It's an open source project. Anyone can contribute to it. If you want to contribute to it, they are welcome in contributions. And it has 3 different languages. It's available in .NET, in Java, and in Python. So whatever programming language that you know, it is supported. And we want the Python one. I'm going to get to the notebooks and then try to see the example for adding the chat history, because we want to add chat history. So I guess this one is the kernel argument chat one. And then if we scroll down a little bit, you will see it's explaining how to create like a chatbot with a conversation history. And then all you need to do is to import the chat history and add it. And then with every prompt that you do, you will need to send along the chat history with it. So all we need to do is to go ahead and redefine our function to include the chat history in it. So I'm gonna go a little bit up and then redefine the prompt. So this is our prompt. So we need to have like a chat, a history prompt, for example. And this one will have a variable for the history inside it. Let's name it chat history. Okay. And then, okay, let's name it history, just history, because I'm gonna name the other stuff chat. So this is our history. So we are just sending the history along with our prompts. Then we need to define this in the inputs of our function, like this, if you remember. So this is the template config, but this is the normal one. We will need to define a new one with a new input for the chat history that we added to our prompt. And this one is called history. This is the chat history. We are doing this live, so let's pray it works. Then we are gonna give it another name. For example, grounded history response. And then this is the chat prompt template config, because chat history. And this needs, the template is the history prompt template. And let's run this one. And now let's add a new chat function. So this is the code to add a function, to add a chat function. So we want to give it a different name, of course. So ChatGPT function, maybe ChatGPT hist function, ChatGPT hist plugin, and the prompt template config is the new one. Then all we need is to use this new chat function. Let me try to make it a new name, maybe chat history function. Yeah, that's better. And then when we try to prompt it, we are going to use this one. Can you see this one? So we are going to have another record for the history. But the history cannot be like anything. It needs to be structured in a specific way. And that's why we're going to get back to the semantic kernel to see how the history looks like. So they say that we have something called chat history that we can use to store our history. So I'm going to copy this code and get here. And this is our chat history. Did we use this variable name before? No, that's good. And then we give it a system message. This one says, you are a helpful chatbot who is good about giving, let's say, movies or movie recommendations. That's better. Now let's run it. And that's what we did right now. And now all we need to do is to use it in our function to send it with the function like the history. So let's do that, but let's do it in the loop so we can test it too live. So right now, this is our result, and we will use here invoke, and we are going to await it because this is an async function, so we need to await it. And we are going to pass along the history. So this is history. Let me check what did I name it. I named it history. Okay, that's good. So history equal chat history. And then we are going to print it. So this is the response. Let's print it like that. And remove this one because we don't need it. Then
also, John, I think you're not sharing your notebook.
I'm not. Yeah, I'm not.
Yeah, okay.
So we don't need this one. I just added the chat history. And the last step is to save the messages like here. So chat history did add user message. And then we are going to save the response from our chat model. So before we do save the user message, after we save the response. So add user message, this is our query. And then add assistant message after it is generated. This is our completions result.
All right, let's run this. Let's see how it works.
Yeah, let's let's hope it works. Hey, are you working? Hey, how can I assist you? Good, that's a good sign. What do you know about the Godfather? This is our popular question today. It's working. It's working. Right now, how can we tell it like something that we know that the history is working from? Can you tell me more about it? So I did not say the Godfather again. If it has history, it's gonna know that I'm talking about the Godfather. Does it? Let's fingers crossed. Let's hope it works. Yes, it does. Certainly, The Godfather is based on the novel, and we have history. But this is an in-memory history, so this is not stored into the database. We will just need to create a new table for it and save it into the database, and that's it. We have a chat history working, and it was a simple addition. We did not have to do a lot to make the history works. It was really simple.
Let's take a look. Let's take a look at all the links that the viewers can go and take a look at this sample and bring this to end. So yeah, this brings to our end of the session. We have the summary page where you can go ahead and take a look at the semantic kernel. You can add other features to your application by going to github.com/Microsoft/semantic kernel. You can also learn more about vCore and its vector search by going to this link, and then finally sign up for free tier for MongoDB, Azure Cosmos DB for MongoDB vCore by going to link aka.ms/try vCore. Also, all this code is in the GitHub repo where we have aka.ms/rag-sk.vcore, so you can follow along and then watch the recording and get started with it. Finally, this brings us to the end of the session. Feel free to give us feedback by going to the reactor session summary page and using the code 222239 to give us a more detailed feedback. To answer some questions that you have in the questions in the chat, I'll reply to them in the text message in the chat history chat message blog instead of answering them. So thank you so much for joining us, Jay. How did it go?
I thought it went great, and Askia, I know next month we will see each other again for another one of these, but I want to say that this is one of the best ones we've done. It was so just really, really deep in there, and I really enjoyed it. And if you saw the audience, they were super engaged the whole time.
Yeah, absolutely.
Cool. So, John, what are you up to next? Is there anything else? How can people find you on the internet?
I just want to have there is a question that is really, really good. It's really good. Guys, this is NoSQL database, or it's not structured. You don't have to have documents. You can have it like a JSON format, and this was not available before. So that's really cool. It's a nice feature because not everyone has their data in docs. You can have a database for a recommendation system that is recommending from, I guess, Kellan can add for the amount of data that can be stored in Azure Cosmos DB. It's a lot. So it can handle lots of data. It's powering ChatGPT. So this is a proof for how big it can handle the load and the data. And that's very different from having a PDFs and some limit over the PDFs and all of that hassle. So, great. And I'm up to doing lots of cool stuff about Cosmos too. So thank you, everyone. Thank you for having me, Jay and Kellan and Askia. Thank you.
And Kellan, anything really interesting coming up, and how's the best way for people to reach out to you?
Yeah, people can reach out to me on LinkedIn, send me a message. I have a few sessions coming up. We're going to present that bill. We're coming up with a lot of new cool features with Azure Cosmos DB for MongoDB vCore. It's going to be, we also just released a filtered vector search and functionality where people can do searches based on some criterias. So I have a video coming up at it pretty soon on the Azure Cosmos DB channel. So please subscribe to that as well, and have a good one.
Yeah, absolutely, everybody. Hey, we'll be back next month. We've got another really great one on generative AI and statistics. We'll have a really great time together, analytics, all that information. But until then, I want to say thank you to our guests today. I want to thank Askia and the Reactor. If you aren't familiar with the Reactor, it is an absolutely wonderful place to find sessions just like this. Of course, you can always head over to the Reactor website, aka.ms/reactor. But anyway, until next time, my name is Jay Gordon. Thanks a lot for being part of the Cosmos DB Global User Group. And remember, if you'd like to take part, we would love to have you as a speaker. You could be just like one of our community members, like John, who came and took part. So just go ahead and check out our intake form, aka.ms/Azure Cosmos DB/user group submission, or reach out to me online. It's pretty easy to find me on LinkedIn. Anyhow, till next time, thanks a lot. And we always appreciate you being part and joining us. So until next time, take care, everybody.
Yeah.